Eighth grade, we are in week 16 talking about electromagnetic waves. Today you should be able to explain the wave-particle theory. So here we have an absolutely gorgeous sunset. You probably know that sunlight travels in waves through space from the sun to the earth. But do you know what light really is? I mean, is it just energy or is it something else? Well, we're about to find out what light may be, and it may be more than it seems. So there was a question about electromagnetic radiation, commonly called light. And light is a transference of energy by waves called electromagnetic waves. These waves consist of vibrating electrical and magnetic fields. Where does electromagnetic energy come from? Well, it's released when electrons return to lower energy levels in atoms. Electromagnetic radiation behaves like continuous waves of energy most of the time. Sometimes, however, electromagnetic radiation seems to behave like discrete or separate particles rather than waves. So, does electromagnetic radiation consist of waves or particles? Well, this question about the nature of electromagnetic radiation was debated by scientists for more than 2 centuries, starting in the 1600s. Some scientists argued that electromagnetic radiation consists of particles that shoot around like tiny bullets. Other scientists argued that electromagnetic radiation consists of waves, like sound waves or water waves. Until the early 1900s, most scientists thought that electromagnetic radiation was either one or the other, and that scientists on the other side of the argument were simply wrong. So here's a thought question. Do you think that electromagnetic radiation is a wave or a particle? I don't know is not an answer. Choose a side, wave or particle. What do you think? Here's a hint. It might not be a question of either or. Is it a wave? Is it a particle? In 1905, the physicist Albert Einstein developed a new theory about electromagnetic radiation. The theory is often called the wave-particle theory. It explains how electromagnetic radiation can behave as both a wave and a particle. Einstein argued that when an electron returns to a lower energy level, it gives off electromagnetic energy. The energy is released as a discrete packet of energy. We now call such a packet of energy a photon. According to Einstein, a photon resembles a particle, but moves like a wave. The theory states that waves of protons traveling through space or matter make up electromagnetic energy or radiation. The energy of a proton isn't a fixed amount of energy. Instead, the amount of energy in a photon depends on the frequency of the electromagnetic value or wave. The frequency of a wave is the number of waves that pass a fixed point in a given amount of time, such as the number of waves per second. In waves with higher frequencies, photons have more energy. After Einstein proposed his theory, evidence was discovered to support it. For example, scientists shone laser light through 2 slits in a barrier made of a material that blocked light. You can see the setup of this type of experiment here. Using a special camera that was very sensitive to light, they took photos of the light that passed through the slits. The photos revealed tiny pinpoints of light passing through the double slits. This seemed to show that light consists of particles. However, if the camera was exposed to the light for a long time, the pinpoints accumulated in bands that resembled interfering waves. Therefore, the experiment showed that light seems to consist of particles that act like waves. Huh. Well, in summary, electromagnetic radiation behaves like waves of energy most of the time, but sometimes it acts like a particle. From the 1600s until the early 1900s, most scientists thought that the electromagnetic radiation consists either of particles or of waves, but not both. In 1905, Albert Einstein proposed the wave-particle theory of electromagnetic radiation. This theory states that the electromagnetic energy is released in discrete packets of energy, which we now call photons, that act like waves. After Einstein presented his theory, scientists found evidence to support it. For example, double-slit experiments showed that light consists of tiny particles that create patterns of interference just as waves do. So if you feel comfortable explaining the wave-particle theory, feel free to move on to the questions. Otherwise, go back to the video again, take a few more notes, and then move on to the questions. Thanks for being here, guys. We'll talk to you later.